Welcome back, everybody, for another deep dive. This time, we're taking a look at AI, specifically a system called Goku.
Yeah, Goku.
It's making some serious waves in video generation. And honestly, I think a lot of people are wondering, like, how does this even work? What does this mean for the future of, well, pretty much everything?
Yeah, it's exciting stuff. And the really cool thing is this isn't just some far-off idea. This isn't science fiction.
Right.
This is a meal system
Yeah.
built by the same folks behind TikTok, ByteDance.
Oh, wow. That's right. Who hasn't spent countless hours just scrolling through TikTok videos?
Right.
It's crazy to think that the technology behind those videos is now being used to create new ones from scratch.
Yeah, absolutely. And these researchers, they were pretty ambitious with this project.
Yeah.
They didn't just want to create any AI. They wanted to build what's called a foundation model. It's kind of like a Swiss Army knife of video generation, capable of tackling all sorts of creative tasks.
Okay, I'm intrigued. So what exactly can this Goku system do? Can it really just make videos from like a few words?
Yeah, you bet. So Goku's actually a family of AI models,
Okay.
and they're designed to generate both images and videos from these text prompts.
Oh, wow.
Imagine typing in a Bengal cat dressed as a shaman, complete with feathers and colorful beads.
Wow.
And boom, you have a video that matches that description perfectly.
Hold on, are you serious? That level of detail just from a text prompt. Okay, you officially have my attention, and it can handle videos.
Yeah, exactly, not just images.
Wow.
In the paper, they have a whole section with examples of images and videos that Goku generated. One where a glass emoji hand is making the peace sign. They even have one where a man emerges from a swarm of butterflies.
No way.
It's crazy.
The results are that realistic.
Oh, they're incredibly realistic. And they're just visually stunning.
Wow, those examples sound incredible. I'm starting to see why this is such a big deal. But let's back up for a second. How does an AI even learn to do something this complex? Like generating video. It's not like you can just show it a bunch of YouTube clips and call it a day, right?
Right, exactly. AI, especially something as advanced as Goku, needs a massive amount of information to learn from. We're talking a data set of over 160 million image-text pairs.
Wow.
And another 36 million video text pairs. So imagine the biggest library you've ever seen.
Yeah.
And then multiply that by, well, a lot.
Okay, that's a lot of data. But did they just scrape the internet for any random images and videos? Because, there's a lot of junk out there.
That's where things get really interesting. See, they didn't just want a huge data set. They wanted a high-quality data set.
Okay, yeah.
So to do that, they built a whole system for filtering and selecting, the best content.
Oh, wow.
And get this, they use something called aesthetic scores.
Aesthetic scores? That almost sounds like they're judging the artistic merit of each image and video. How do they even measure something like that?
It's a fascinating process. They actually combined a few different approaches. First they used algorithms to analyze things like the resolution, the clarity, and the composition. But they also had human evaluators, real people, looking at these images and videos just to make sure they were visually interesting and engager.
So it's kind of like a blend of objective measures and subjective human judgment, which makes sense because, beauty's in the eye of the beholder, right?
Exactly.
But wait, you mentioned earlier that they actually used a different approach for videos, something about a motion score.
Yeah, that's right, because when it comes to video, you have this added dimension of movement over time, right?
Yeah.
So in addition to just the aesthetics, they had to consider how dynamic and engaging the motion was.
Okay.
So they use this technique called optical flow, which essentially analyzes how objects are moving within a video. So think of it like tracking the path of a soccer ball during a game.
Okay, so they were looking for videos that had a good flow to them, where the movement was captivating and just made you want to keep watching.
Exactly. And all of that effort paid off. This really meticulous approach to data curation, it's a big part of why Goku is so good at what it does.
Okay, so we've got this massive, beautifully curated data set.
Right.
But how does all of that information get translated into an AI that can create videos from scratch? What's going on under the hood?
Yeah, you're right. There must be some pretty sophisticated machinery under the hood.
Yeah.
And there is. So Goku actually uses two key components, a variational autoencoder, or VAE for short,
Okay.
and a transformer.
Two components with very complex names. Can we break those down a little bit?
Sure.
What is this variational autoencoder?
All right, so imagine you're trying to explain a complex concept to someone, but you can only use a limited number of words.
Okay, yeah.
You would have to find a way to kind of condense that information down to its most essential elements, right?
Right.
That's kind of what the VAE does. It takes the visual information from images and videos, and compresses it into a simpler code, something that the AI can actually understand.
So it's like creating a shorthand for visual information.
Exactly.
Okay, that makes sense. What about the transformer? What role does that play?
The transformer, that's like the brains of the operation.
Okay.
So it takes this compressed code from the VAE, and it uses it to figure out how different elements relate to each other.
Hmm.
For example, if the text prompt says cat riding a skateboard, the transformer needs to understand that the cat is the one doing the riding,
Right, yeah.
and the skateboard is what it's riding on.
So it's like the transformer is making sense of the scene, figuring out how all the pieces fit together based on that text prompt.
Precisely. And it does this using a really clever mathematical trick called rectified flow, which helps the AI learn faster and more efficiently.
Rectified flow sounds very fancy. I'm sensing a theme here. Massive data sets, complex models, and some serious mathematical firepower. It sounds like building an AI like Goku takes a lot of brain power.
You're not wrong. And we haven't even touched on the training process yet. To get Goku to this level of performance, the researchers had to get creative not just with the model itself, but also with how they trained it.
Okay, I am officially hooked. Tell me more about this training process. How do you even begin to teach an AI something as complex as video generation? Did they, build a special AI boot camp? What happened?
It was definitely a complex undertaking. And remember how we talked about Goku being like a family of models?
Yeah.
Well, they actually trained it in stages. They started with something a bit simpler, text-to-image generation.
Oh, okay. So they started by teaching it how to create still images from text prompts, lay the groundwork before moving on to the more challenging task of video.
That's exactly right. They wanted to make sure Goku had a really solid foundation in understanding that relationship between words and visuals. Before tackling the complexities of video,
Makes sense. It's like learning to walk before you run, right? But I'm guessing even training for text-to-image generation with a data set that massive must have been a huge challenge. Did they just have a supercomputer just chugging away for months on end?
even with powerful computers, training on that scale requires some serious ingenuity. They had to get creative. Imagine trying to bake a giant cake, but your oven is too small.
Uh-oh.
You'd have to find a way to bake it in pieces and then assemble it later.
So they broke down the training process into smaller, more manageable chunks.
Exactly.
Clever, but I'm dying to know more about how they actually put all these pieces together to train Goku. Did they have a secret recipe or something?
Well, that's a story for part 2 of our deep dive.
Oh, come on. You can't leave me hanging like that.
Don't worry, we'll get into all the juicy details of the training process next time.
You promise.
I promise. We'll explore the challenges they faced, the creative solutions they came up with, and of course the amazing results that they achieved.
All right, all right. I'll try to be patient, but you better believe I'll be back for part 2.
I'm sure you will. Welcome back. Glad to have you for part 2. So last time we were talking about how they trained Goku with all that data, right?
You bet. You left me hanging with that boking a giant cake analogy. I gotta know what kind of oven they built to cook up this AI recipe.
Well, think of their oven as thousands of these specialized computer processors. They're called GPUs.
Okay.
And they're kind of like the workhorses of AI training, capable of crunching through massive amounts of data really, really fast.
Okay, thousands of GPUs. That sounds pretty intense. But I'm guessing even with all that power, training an AI like Goku would still take a ton of time, right?
Absolutely. But it's not just about raw power,
Right.
It's also about how you use it.
Okay.
So the researchers had to come up with these clever strategies to really make the most of those resources.
Okay.
One technique they used is called sequence parallelism. Think of it like dividing up a big task into smaller chunks that could be worked on at the same time.
Ah, so it's like having a whole team of chefs working on different parts of the meal at the same time.
Exactly, instead of just one chef trying to do everything themselves. And they also use this technique called activation checkpointing. Imagine you're reading a book, right?
Mm-hmm.
You don't try to memorize every single word.
Right.
You jot down the key points so you can go back and reference them later. Well, activation checkpointing does something similar. It helps Goku conserve memory and run more efficiently.
Smart. Sounds like they were really thinking outside the box to, optimize this training process.
Yeah.
Any other tricks up their sleeve?
Well, when you're dealing with thousands of computers, things can go wrong.
Oh, yeah, for sure.
A machine might crash, you might have a network issue, so they had to build in safeguards to make sure that the training could keep going, even if some computers went offline.
Oh, that's crucial. You wouldn't want to lose, days or even weeks of progress because of one computer having a little hiccup. It's like having a backup generator for your AI training system.
Exactly. They also used a special system called byte checkpoint to regularly save their progress, like hitting save on a document.
Right, so they've got all these safeguards in place, and they're using all these techniques to, speed up and optimize the training. But I'm curious, how do they actually know if Goku's learning? What's their measure of success?
That's where these benchmarks come in.
Okay.
Imagine you're trying to learn a new language.
Yeah.
You might take a test to see how well you're doing.
Right.
Same idea with AI. These benchmarks evaluate Goku's ability to generate images and videos that match the text prompts.
So it's not just about creating something visually cool, it has to actually accurately reflect the intent of the user?
Precisely.
Okay. But what were these benchmarks like? Were they just like random prompts?
They actually used a variety of different benchmarks, each designed to test different aspects of Goku's capabilities. Some focus on the visual quality of the output, others on the alignment between the text prompt and the generated content, and some even tested how well Goku could handle really complex and detailed prompts.
So they were really putting Goku through its paces.
Oh yeah,
And I'm guessing, given all the effort they put into this, the results were pretty impressive.
you're right. Goku consistently outperformed other state-of-the-art models, even commercial systems that are already out there. And it was particularly good at handling these detailed prompts. One example from the paper involves a prompt about a drone flying over a coral reef, capturing footage of all the amazing marine life below. So let's say other models struggle to actually create the drone correctly, or they generate these images that were blurry or distorted. But Goku produced this incredibly realistic video
Wow.
that accurately matched all those details in the prompt.
That's incredible. Sounds like Goku really shines when it comes to translating those complex ideas into visuals. I can definitely see why the researchers are so excited about this. But wait, hold on. We've been talking a lot about text-to-video generation, but you mentioned earlier that Goku can also create videos from images. Is that right?
Yeah, that's right. It's called image-to-video generation.
Okay.
It's like bringing a still image to life.
Wow.
Imagine you have a picture of a frozen waterfall.
Okay.
Goku can take that image and then generate a video of the water cascading down, creating that sense of motion and energy.
Wow, that does sound like magic. So they're not just creating simple animations, they're actually generating new video content based on a single image. How is that even possible?
It's based on the same principles, but with a twist. Remember how we talked about the VAE compressing that visual information?
Yeah.
Well, in this case, it starts with the information from the still image,
Okay.
and then it uses the transformer to figure out how to create a sequence of frames that would turn that image into a video.
So it's like the transformer is imagining what might have happened before and after that moment, captured in the still image.
Exactly.
That's wild.
It is. And the really remarkable thing is, they didn't need a massive amount of additional data to teach Goku this new trick. They just showed it a relatively small number of image-video pairs, and it was able to generalize from there.
That's impressive. It suggests that Goku's learning more than just how to follow instructions.
Right.
It's developing like a deeper understanding of how the world works.
You're hitting on a really important point. Goku isn't just mimicking what it sees in the data.
Yeah.
It's learning these underlying principles that allow it to generate new and creative content.
That's exciting and a little bit scary, to be honest. Like, if AI can create videos that are this realistic, what does that mean for filmmaking? Or even just how we consume media in general?
Those are exactly the kinds of questions we're going to explore in part 3 of our deep dive.
Okay.
We've seen what Goku can do, but now it's time to think about the bigger picture.
Okay.
The potential impact of this technology on society, the ethical considerations, and the questions that it raises about the very nature of creativity.
All right, you've officially piqued my interest. I can't wait to tackle those big questions with you in part 3. Okay, so we've talked about what Goku can do, the tech behind it, all that good stuff.
Right.
But now I kind of want to get into those big questions surrounding Goku.
Yeah.
We've seen the potential, but what does it all mean? How is this tech really going to change things, for everyday people like you and me?
That's the million-dollar question, isn't it? We see all these crazy advancements in AI, and we always wonder, is this really going to change my life? And I think in the case of Goku, yeah, it probably will.
Really? Okay, what kind of changes are we talking about? Paint me a picture.
Well, just think about content creation for a second. Right now, making high-quality videos, it's expensive. It takes forever.
Oh, absolutely.
You need all this special equipment, fancy editing software. You got to know what you're doing. But with Goku, suddenly anyone who has a decent idea, a text prompt, bam, they can bring that vision to life.
So you're saying Goku could democratize video creation?
Exactly.
Make it easier for people who don't have those resources or the expertise?
Exactly. Imagine bloggers creating these dynamic videos to go along with their posts. Small businesses making professional-looking ads without, breaking the bank. Even teachers, they could generate custom educational content just for their students.
Wow, yeah, those are some really great examples. It's like we're on the verge of this whole new era of storytelling where making a video is as simple as writing a blog post or even just sending a text message.
And it's not just about practicality either. Think about art, entertainment.
Yeah, for sure.
Artists could use Goku to explore totally new forms of expression. Musicians could make visual accompaniments for their music. Even filmmakers, imagine them using this to play around with different storytelling techniques.
Oh, yeah. I could totally see a whole new genre of art emerging, one that blends human creativity with AI. I mean, we might even start to see these really interesting collaborations where the line between the creator and the tool gets a little fuzzy.
That's a really interesting thought, actually, because it brings up questions about creativity in general, right?
Mm-hmm.
Is something less creative just because it is made by an AI? Or is it just a new form of artistic expression?
Whoa. Okay, those are some deep kind of philosophical questions. But it's not all sunshine and roses, right?
Of course
I
not.
mean, there have to be some downsides to a technology this powerful.
You're absolutely right. Every powerful tool has the potential to be misused. And one of the biggest concerns is the spread of misinformation.
Oh, yeah.
We're already seeing how easy it is to manipulate images and videos. And with a tool like Goku creating these realistic fakes, it becomes even easier.
That is a scary thought. It's like giving anyone the power to create their own reality.
Right. So how do we even start to address that?
Yeah.
Well, it's going to take a multi-pronged approach, right?
Okay.
We need to develop new tools to detect these fake videos. We have to educate people about the potential for manipulation. And most importantly, we need to have these open conversations about how to use these technologies responsibly.
It sounds like we're really entering a whole new world where we need to be way more careful about what we're seeing, what we're hearing, what we're believing.
Absolutely. And it's not just about being skeptical. It's about understanding the technology, how it works.
Yeah.
We need to know how AI is changing how we create and consume information.
So it's not just about learning to spot the fakes, it's about getting a better grasp of the tech itself so we can make informed decisions about its impact on society.
Exactly. And that's what we've tried to do in this deep dive, right?
Yeah.
We explored how Goku works, its potential, and the ethical challenges it brings up.
It's been a fascinating journey.
It has.
I feel like I learned a lot, not just about Goku, but about the broader impact of AI and its role in, shaping our future.
And we barely scratched the surface. This is just the beginning of a much bigger conversation
That's for sure.
about the intersection of technology, creativity, and humanity itself.
All right, listeners, we've given you a taste of what Goku is all about, the amazing potential it has. But now it's your turn. What do you think about the future of AI video generation? How will this impact your life, your work, your community?
The future's being written right now. And honestly, it's up to all of us to shape it. So stay curious, keep exploring, and let's see what incredible things we can create together.
That's a wrap on our deep dive into the world of Goku. Thanks for joining us. CICAC.